Assalamu alaikum. Welcome to the demo class. Now I will give demo class on extraction of shrimp chitosan and its application on shelf life extension of tomato. Let's talk about introduction. Shrimp is one of the most important fisheries product worldwide, including Bangladesh. Shrimp industries generate 45 to 55% biowaste of the weight of raw shrimp. This biowaste can be used to produce value-added products such as chitin, chitosan, etc. Chitosan is a modified natural carbohydrate polymer which has been found in a wide range of natural resources such as crustaceans, fungi, insects, and some algae. Chitosan is a fiber-like substance derived from chitin, a homopolymer of beta-1,4 linked N-acetyl D-glucosamine. Chitin and chitosan have attained increasing commercial interest due to their excellent properties, including unique cationic character, biocompatibility, biodegradability, absorption, non-toxicity, ability to form films, and to chelate metal ions. Chitosan offers a wide range of unique applications in food sector, including preservations, production of value-added products, water purification, etc. Chitosan as edible coating are applied on fruits and vegetables to extend shelf life. Chitosan has been approved by US FDA as a grass food additive. Chitosan have excellent film-forming properties, antifungal activity, biodegradable properties, and safety to human and environment. Chitosan coating can effectively delay ripening, reduce decay, reduce post-harvest loss, and extend the storage life of tomato fruits. Now let's talk about objectives of this experiment. To extract chitosan from shrimp shell waste, to investigate the effect of chitosan coating on post-harvest quality of tomato fruits. Materials: we use shrimp shell, hydrochloric acid, sodium hydroxide, acetic acid, and tomato. Now let's talk about method of chitosan extraction. First, we collect shrimp shell waste, then we autolyze it at 28 degrees centigrade for 24 hours. Then we remove mineral by demineralization process for 16 hours. Then we remove protein by deproteinization in 4% sodium hydroxide solution at 28 degrees centigrade for 20 hours. Then we get chitin. Then we remove acid from chitin by deacetylation using sodium hydroxide solution in different concentration at 65 degrees centigrade for 20 hours. Then we get finally chitosan. Then we prepare chitosan coating preparation. We use 0.6% glacial acetic acid and 25% glycerol as plasticizer to chitosan. Then we mix it with magnetic stirrer. Then we adjust pH up to 5.6 and we add 1 molar sodium hydroxide solutions. Chitosan coating application. We collect green tomato from local market. Then we disinfected it using hot water treatment at 42.5 degrees centigrade for 30 minutes. Then we wash it at air dry, dipping into chitosan emulsion for 1 minute, air dry for 2 hours. Then we store it at ambient conditions. Shelf-life extension of tomato. There are 3 treatments are applied to investigate the storage life of tomato, and they are control 0.25% chitosans, 0.25% chitosan plus 1% perforated low density polyethylene, and 0.25% chitosan and paper bag. Chitosan coating application on tomato and shelf life study. The following parameters will be observed during storage of tomato, and they are weight loss, color, total soluble solid, pH, disease incidence, disease severity, and shelf life of tomato. Now let's talk about result and discussion. T0 means control, T1 0.25% chitosan, T2 0.25% chitosan plus paperback, and T3 is 0.25% chitosan plus 1% perforated low density polyethylene. Analysis of shrimp washed and purified chitosan. Here we can see moisture content, ash content, and yield of shrimp washed and chitosan. Now let's talk about the effect of post-harvest treatment on weight loss of tomato. By using one-way ANOVA test, we plot this table. We can understand properly by seeing graph. Here you can see a graph that represent there's three treatments. Now, effect of post-harvest treatment on weight loss of tomato. Here you can see T3 lines gives more perfect and accurate results. That means T3 is 0.25% chitosan and 1% perforated low density polyethylene. That means T3 gives the best result, and its weight loss is less than other three treatments. Effect of post-harvest treatment on color score of tomato. By one animal test, we plot this table, and from graph we can understand properly and more accurately. Here you can see again T3 line give the best color score than other three treatment. Here you can see this four lines, and T3 gives the best result. Now let's talk about effect of post-harvest treatment on total soluble solid TSS of tomato. From graph we can understand more accurately. Here you can see TSS change of tomato. Now let's talk about pH of tomato. From graph we can understand more accurately. Here we can see the graph of pH change of tomato. Now let's talk about effect of post-harvest treatment on disease incidence of tomato. Now conclusions. Treatments purified chitosan obtain 10.12% moisture and 0.31% ash content. Yield of purified chitosan based on shrimp washed was 16%. Among the post-harvest treatment, control tomato showed significantly the maximum on weight loss, 14.5%, while T3 0.25% chitosan plus 1% perforated LDP sample showed minimum on this parameter, 5.6 parts, 5.7% weight loss respectively. T3, that means 0.25% chitosan plus 1% perforated LDP sample showed significantly better color score, 5.6. All the treatments had no significant effect on TSS and pH up to 12 days of storage period. Chitosan coating and packaging materials has significant effect on disease incidence, which showed that 20% uncoated tomatoes spoiled up to 12 days of storage, where for all other samples where disease incidence rate is only 6.66%. That means this three treatment 0.25% chitosan, then 0.25% chitosan plus paperback, and 0.25% chitosan plus LDP. These three treatments give the best score in this incidence rate, and that is 6.66%. And uncoated, that is control tomato, showed that 20% this incidence. Thank you all. Assalamu alaikum.